Hello students, greetings of the day. This is your Eknath sir, faculty from VIP classes. Okay, so today we'll talk about kinematics 2D motion or motion in a plane. Okay, projectile motion. या बच्चों टुडे आज हम 2D मोशन या प्रोजेक्टाइल मोशन के बारे में सुनेंगे. सो क्या होता है प्रोजेक्टाइल? सो प्रोजेक्टाइल किसे कहते हैं? सो एनी ऑब्जेक्ट थ्रोन इन द एयर और not only air, so any object thrown, it may be a gravitational field, it may be electric field, it may be a magnetic field, we can call it as a projectile. Okay, so any object thrown can be called as a projectile, and whose motion later governed by, if it is in gravitational field, by gravity, if it is electric field, by electric field, if it is in a magnetic field, whose motion is governed, okay, in a magnetic field, can be called as a projectile. Okay, now currently in 2D motion, here motion in the plane, we restrict our attention for motion of an object in gravitational field. Okay, see in 1D motion we have seen a body projected vertically upward, also a projectile. A body projected horizontally, projectile. A body projected some angle, also a projectile. So now here we talk, anyhow we have discussed in 1D and 2D motion that motion of object constrained to move only along one direction. एक ही डायरेक्शन में जब ऑब्जेक्ट मूव होता है ना, हम उसके बारे में बात किए, उसको हम बोलते हैं 1D मोशन, है ना, वन डायमेंशनल मोशन. एंड ऑल्सो वी स्टडी यूनिफॉर्मली एक्सेलरेटेड मोशन, नॉन यूनिफॉर्मली एक्सेलरेटेड मोशन वी हैव स्टडीड. नाउ वी आर गोइंग टू टॉक अबाउट अ मोशन इन ए प्लेन. दैट मीन्स if the object is moving in a plane, so it has both x coordinate as well as y coordinates. So for example, if I say an object having x coordinate, x is equal to some t plus 2, whose coordinates are changing. So find the instantaneous velocity of the particle at some, for example, 2 seconds. If I ask you, so what do you say? So its x coordinate is changing, so the velocity in x direction we call it as dx by dt, which is equal to, and here we say y coordinate, we call it as dy by dt, that is 1 plus 0. How much? 1 meter per second. So derivative of t is 1, constant is 2 is 0. So net velocity of the body is x component plus y component, will say, that is this will be 2i cap plus 1j cap. So here when object is moving, velocity in x direction positive and y direction also positive. So net velocity by vector law, it will be like this net velocity. You can make also some angle theta. So tan theta will be vy component by x component. Yes or no? So y component is 1, x component is 2. So theta becomes now tan inverse of 1 by 2 with the horizontal. Okay, so like this, when an object moves along x as well as y direction simultaneously, its motion is constrained to, okay, constrained to move in a what? Plane. This is called what? You can say two coordinates are required at any point to locate the position of the particle. So we can call motion in a plane, this one. Okay, so like wise, now you can talk here, we are basically talking about when object is projected at some angle theta. Okay, so and that is called, we can call it as oblique projectile. What projectile? So if an object is thrown at some angle other than 90 degrees, 90 degrees 1D motion becomes, isn't it? So now or horizontal or vertical, but I am talking about some angle here. So if I say, for example, if you take reference axis here, x axis, y axis, x as horizontal, if I throw an object some angle theta, you can call it as oblique projectile. Okay, so what happens here, actually in the absence of gravity, this object would have gone straight like this, but as the gravity acting downwards, so its motion, what happens, the body tries to move, because of gravity in the direction, somewhere else it will land. Now at any position, if you locate the position of the particle, say px comma y, so its x coordinate, y perpendicular, this x coordinate, y perpendicular, this is what? Y coordinate. So when you are throwing the particle, simultaneously particle is moving along x direction as well as y direction, isn't it? इसको x में भी जा रहा है बॉडी, y में भी जा रहा है. सो दो कोऑर्डिनेट्स है इसके लिए, x कोऑर्डिनेट भी है, y कोऑर्डिनेट भी है. सो फिर x डायरेक्शन में डिस्प्लेसमेंट है, तो इसको कुछ इस डायरेक्शन में वेलोसिटी होना चाहिए. So when you are throwing the particle here like this, some velocity u, if you drop a perpendicular, it has velocity in x direction, say ux. सिमिलर जब पार्टिकल वाई डायरेक्शन में जा रहा है तो उसको वेलोसिटी इस डायरेक्शन में होना चाहिए, तो वाई डायरेक्शन में यू वाई मानेंगे. सो अगर जब हम इसका मैग्नीट्यूड यू मानते हैं, अगर एंगल थीटा रहा तो हम वेक्टर्स में देखें इसका एक्स कंपोनेंट को हम मान रहे हैं यू एक्स, से कितना होगा, दिस विल बी यू कॉस थीटा एंड दिस लेंथ ऑफ दिस वेलोसिटी वेक्टर, दिस विल बी हाउ मच, दिस विल बी हियर यू साइन थीटा. Okay, now we'd like to know what is this trajectory equation. So in terms of x and y we would like to understand. So when the particle is moving in xy at any position after some time t, if x direction displacement and y direction displacement if you want to find, तो क्या करना चाहिए बोलिए. Yes, x में कितना गया, y में कितना गया हमें चाहिए. Getting. So now if you go x direction में gravity है, उसका वैल्यू कांस्टेंट होगा यहाँ. क्यों? एक्स डायरेक्शन में ग्रेविटी नहीं है, ओनली वाई डायरेक्शन में है ग्रेविटी. सो ग्रेविटी इज ओनली इन वाई डायरेक्शन, एक्स डायरेक्शन नो ग्रेविटी. इफ वांट टेक कंपोनेंट आल्सो टेक कंपोनेंट ऑफ एम जी इन हॉरिजॉन्टल डायरेक्शन, एम जी cos 90 which will be here 0. Okay, so in x direction velocity is what, constant, because no effect of force. No force means no acceleration. No acceleration means what here, velocity is constant. Therefore x direction velocity is u cos theta and initial velocity in y direction is u sin theta, and in x direction acceleration 0 and in y direction acceleration, if I take vertically upward positive, downward will be negative, so this will be minus g. Okay, now after some time it will go travel x distance, here travel some y distance. So in t seconds how much travel x direction, velocity is constant. So when velocity is constant, formula velocity displacement by time, displacement will be velocity into time. So you can find out here velocity into time. So therefore this x becomes velocity how much, right, u cos theta into t. So from this we'll get this time will be x by u cos theta, right. Similarly in y direction, if you see y direction ay minus g, so you can also write y direction acceleration is constant, so ut plus half a t square, I am calling it as y direction. So you can write down y direction initial velocity u sin theta, ay is minus g minus half g t square. Okay, you are getting. So now here y direction, so ut, so u sin theta into t minus half gt square. Now here I can see that the motion in a plane in two directional motion, so can be assumed to be okay xy direction, no, xy motion in a plane. So I can assume this as combined motion of two independent direction, which is x and y. So at an instant of time, to locate the position we require two coordinates. So I can understand this 2D motion as sum of two independent motions which are x and y directions. Okay, so now I want to know its trajectory path. Path means always in terms of only x and y. So if substitute the value of t in this equation 2, we understand here now y will be u sin theta into t. T means how much here, x by u cos theta minus half g into x square by u square cos square theta. So here u get cancelled, so y becomes now x tan theta minus g by 2 u square cos square theta into what, x square. Okay, so now at any time position px comma y we found. So x direction velocity constant, so displacement is equal to velocity into time. In y direction acceleration is there, body retarding in y direction. So at any time t, position y direction is ut plus half a t square, where in y direction. So uy is u sin theta, ay is minus z. So we'll get the equation, and our aim is to find trajectory equation in terms of only x and y. So substitute the value of t and we got. So here if you see, for a given velocity of projection and for a given velocity of projection for a given angle of projection, theta constant, u constant. So if I take this tan theta as a and this term as b, I can write this one as ax minus bx square. where where A will be tan theta, okay, B will be how much beta? G by 2 u square cos square theta. These terms are constant and this equation indicates equation of a parabola. Kya bola? Equation of a parabola. Therefore, when you project some particle at some angle theta, okay, so in gravitational field here, so this particle following this kind of path, this is a curved path, and you have shown that this equation of this trajectory path is ax minus bx square. Okay, now so while this is going here, we can say the maximum horizontal distance traced, this we call it as range, and this maximum vertical distance we traced as called maximum height, and the time taken to move along this path or to time taken to trace this particular what? Horizontal distance we call time of flight. So now if you want to find time of flight, see in t seconds it is going like this and falling here, so it's in t seconds its vertical displacement is 0. So in the time taken, vertical displacement 0, the time we are calling as time of flight. So if I write vertical equation, already we know what formula we said. Second equation, u sin theta, so t is capital T minus half g t square, this value must be 0. Vertical displacement means, so you have u sin theta is equal to half g t square. So from this we understand, this is t here, right? U sin theta into t. So 1t get cancelled. So t becomes now 2u sin theta by g. Where 2 into u sin theta means y component by g. So this is the time in which particle is moving from here to here like this. The same time it is this much displacement. So vertical displacement becoming 0 and horizontal displacement is there. And this time taken is called time of flight. So you can call time of flight is the time taken to reach ground or time through which the particle is in journey before landing. Okay. Now during this time, how much horizontal distance traveled? No, that we are calling as what, students? Range. What is range now? Come on everyone. The maximum horizontal distance. What is range? The maximum horizontal distance. Maximum horizontal distance traced by a particle is called range. So that particular range will be, as you go in x direction, there is no effect of gravity, force 0, acceleration 0, that means velocity is constant. Okay, so that becomes now how much now? So displacement will be velocity into time, so that velocity is u cos theta into time, how much beta? 2u sin theta by g. So you can also write this expression as u square 2 sin theta cos theta divided by g. Okay, so you can write it also as u square sin 2 theta divided by g, or you can also write this one as see here, this is 2, right? U sin theta is y component, u cos theta x component. I can also write 2 times x component into y component by g. This also you can write as range formula. So the maximum horizontal distance traced by a particle is called range. Okay, and the time taken is called time of flight. Then so this height is called what height? Vertical height. So in vertical direction, so this velocity is uy and this velocity is here ux, isn't it? So we want vertical displacement trace, that is called maximum height. See, if the velocity in y direction would not have become 0, will it have come back? No, isn't it? So that means in y direction its velocity here, if you project like this, as it is going, and here it's not going behind this height, means here velocity in y direction how much became? 0. But the velocity is not 0. Y component of velocity is 0. Keep in mind. This is x component and this is vertical downward gravity is acting. Okay. Now our aim is to find, so initial y direction velocity uy, u sin theta, and x direction anyhow you know, all of you, cos theta for this angle of theta. So in y direction initial velocity is u sin theta, gravity acting downward, ay is minus g. So now final velocity in y direction becomes 0 and displacement in y direction is h. So if I take third equation here, v square minus u square is equal to s. Yes or no? So this is in y direction. So velocity in y direction becoming how much? 0 after some time. And this is uy square 2 into ay is minus g, sy is vertical height. This minus either side you can cancel. So h becomes how much better now? Uy component whole square by 2g. Y component how much we have seen? U sin theta. So you can also write u square sin square theta by 2g. Okay. So now this is what? Maximum height. So now you can summarize. Path of the projectile is parabola. Trajectory equation is x tan theta minus g by 2 u square cos square theta into x square. Or we have seen y is equal to ax minus bx square, where a value is tan theta and this value is what? B. And we have seen time of flight formula is 2u sin theta by z. And we have seen range formula. You can also write this as 2 times y component by g. Range is 2 times x component into y component by g. Is also equal to x component into t. Why? X direction में velocity constant है. Or one more formula in terms of theta we have seen. U square sin 2 theta by g. This is also for range. Okay. Then we have seen maximum height. This is y component whole square by 2g. The way we have seen in 1D motion. When you throw the body vertically upwards, how much maximum height? Uy square by 2g. Or you can also write this one as what beta? U square sin square theta by 2g. Okay. So this is how we have seen oblique projectile. So any object thrown in the air at an angle theta, or not only theta, any thrown you can call as a projectile. Okay, so it has at any instant of time, it has 2 coordinates. If you want to find velocity in x direction, differentiate, y direction, differentiate, net velocity is sum of the velocity vectors. And next we have seen oblique projectile thrown at some angle theta other than 90. Then instant of time, particular position p, x direction, y direction we saw. For trajectory equation, you substitute the value of time from this one and we got the trajectory equation. Then range, time of flight and maximum height. Okay, so these are things which we have seen as a derivations. Okay, and the next class we talk about a few numericals based on this oblique projectile, and then we go for horizontal projectile. Okay, so we'll stop here, and please do subscribe and share, like and comment. Okay, thank you all. Take care.